That's why I'm recording stuff at the same time because you're my first class of the day. Okay, so identifying like terms. First of all, we have to know a couple of things. We have to know what is a term. Okay? And again, you guys don't have to write all of this down. I'm going to tell you when you have to write something in your notes. Okay? A term is a constant a variable, or a combination separated by a plus or minus sign. Okay? So when I look at this first example here, it says 7x plus 5 minus 3y squared plus y minus x. How many terms do you think are in that expression? And those of you at home, you can just take a guess. I'll explain it more in a second, but you can type it in the chat. How many terms do you think are in there? Do you think there's 1? Do you think there's 5? Do you think there's 4? Do you think there's 7? How many terms do you think? Those of you in class, put a number up. How many terms do you think there are? Knowing that I haven't explained it very well. Just take a random guess. I'm seeing lots of 4s or maybe 5. Okay, so terms are separated by plus or minus signs. Okay, so if I drew some lines here, the plus or minus sign separates all the terms. So how many are there? There'd be 1, 2, 3, 4, 5 terms. Does that kind of make sense? So how many terms are in the second one? In the second expression, how many terms are there? I'm seeing a few people at home saying that there are 6, and I see lots of 6s here. You are correct. 15y is a term, 16 is a term, this is a term. So those are, there are 6, not 16, 6 terms. Okay, questions on what a term is? Okay, then we're going to talk a little bit about coefficients. We said this word yesterday. The coefficient is a number multiplied by a variable, and it's always written in front of the variable. Okay, so if I have the term 7x, what's the coefficient in that term? It's always a number. Go ahead, Brady. The 7. Okay, the 7 is the coefficient. The x is a variable. What's the coefficient in 3y? I see some people typing it in at home. The coefficient is, go ahead, Lizzie. 3. It's the number in front of the letter. So what's the coefficient in 2p? Everyone, shout it out. 2. What's the coefficient on a? Not a. There is one. It's not 0. What number could we put in front of the a so that when we multiply it, it would stay the same? Raylan? 1. Okay? So when you see a letter by itself, you can always put a 1 in front of it. Okay? Always. So the 1 would be the coefficient of that. Questions on that part? Okay, then we're going to talk about like terms. Okay, in your notes, I want you to write this. I want you to write like terms. This is going to be super, super important. Like terms are terms that have the same variable raised to the same power. So put that definition in your notes. Like terms. Terms that have the same variable raised to the same power. And then it says note constants are like terms. So they don't have a variable at all. So they go together. Okay, so you can see some examples up here. 3x and 2x are like terms. Okay, it doesn't, the 3 and the 2 don't matter at all. It's the x's. They both have the variable x, and there's no exponent on it. So they're like terms. Okay. W and 7w are like terms. Because they both have a w. I could put a 1 in front of the w. They're still like terms. 5 and 1.8. They are like terms. Because they're just numbers. They don't have a letter at all. So they are like terms. Okay. 5x squared and 2x squared. Notice how these are a little bit different? They're not like these x's up here. These are different because they have the little 2. They have the exponent. So you can't say that an x and an x squared are alike. They're not. They're different. This is like an apple. This is an orange. They're different. Okay. 6a and 8a, they are like, because they have just the a. And then these are constants, so they're like. They're alike. Okay, so I'm going to write a set of terms, and I want you guys in class, give me a thumbs up or a thumbs down. You guys at home type yes or no if you think they're like terms or not. Okay? Is x and x squared like terms? Thumbs up or thumbs down at home type yes or no. And you should be doing this. Absolutely not. These are not like terms. Can somebody tell me why they are not like terms? Brady.
Because all the exponent.
Yeah, the exponent, the square. Okay, that means they're not like terms. How about 3x and 3y? Yes or no? Are those like terms? Thumbs up if you would say yes, thumbs down if you say no. At home, type yes or no. Are they like terms? No, they are not. Somebody tell me why they are not like terms. Brady.
They don't have the same variable.
They don't have the same variable. One is an x, one is a y. They are different. Okay? How about 7 squared and x squared? Thumbs up or thumbs down? Are they like terms? Seeing some yeses and some nos at home. Here I'm seeing two people yes. The answer is actually no. They are not like terms. Can anybody tell me why they are not like terms? T.
They do not have the same variable, but they are the same power.
Right. So this has to be correct first. They have to have the same variable. If they have the same letter, then we look for the power. Okay? How about this one? 3 squared and 7. Are they like terms? This is actually a trick question. Yes, they are. Because remember I said they have to have the same variable first? They don't have a variable. What is 3 squared? 9. So those are just two numbers. So yes, they are like terms. Okay, does this kind of make sense? Okay, so I want you, we're going to start here. I want you to draw 4 kind of circles across your paper like this. At home, I want you to draw 4 ovals across your paper. This is what you're going to have to do on your homework. It says identify like terms. So you're going to have to put the like terms together in a circle. Okay? And here's how we're going to do that. I'm going to start with 2B, and I'm going to put that in the first circle, or the first oval. Okay? And then I'm going to go to the next term, B to the 6th power. Can that go in this first one? No. Why not? Why can't it go here? Brady. It doesn't have the power. So the B to the 6th power goes in a new oval. So write it in the second oval, B to the 6th power. Okay, now we're at the B. Where should I put the B? T, go ahead. With the 2B. So B is going to go here. Okay, then we have X to the 4th power. Where should that go? What do you think? Addison, can it go in either of these? No. It's an X. It's different. These have B's. So this has to go here, X to the 4th power. Okay, 3B to the 6th power goes where? With the B to the 6th power, because it has the same variable with the same power. And then we have 2x squared. Can that go with this x? Why not? Why can't it go there, T?
It doesn't have the same
Good. So it's different. So 2x squared goes there. Questions on that? Questions so far from anybody at home? Is kind of making sense, hopefully. Okay, let's try another one. Okay, so draw 4 circles again. And let's just work our way down the list again. Start by putting a 6 in the first circle. Cross it off. Can the 2n go with the 6? No. So it gets its own circle. How about 3n squared? It gets its own, right? Why does it get its own? Why can't it go with this n? They both have n's. Caitlin. They don't have the same power, so they have to be separated. Okay? How about 6m squared? Can it go with the n squared? Why not? P.
doesn't have the same variable.
It's not the same letter, so 6m squared goes by its own. Okay, the n. Where does the n go? What number is in front of the n, even though we don't see it? 1. So we could put a 1 there if that helps you. Where does that go, Lizzie?
With the 2.
With the 2n. And then the 7. Where should the 7 go? Caitlin? With the 6, because neither one of those have a letter. Okay? So I'm going to ask everybody to try this one on your own. Even those of you at home, you don't have to type anything in, but just try it. Put it in your notes. Okay, so I'm gonna show you the correct answer. The 3 squared, I'm gonna put in the first circle. The y to the third power can't go with that because this has a y, but 3 doesn't. Got those done. 3y to the second power can't go with either of those. It has a y, but it doesn't have the same exponent. So that's gonna go here. The y, can that go in any of these first 3? No. Because this has an exponent of a 3 and this one has an exponent of a 2. So the y goes here. Well, now we have another y cubed, y to the third power. That can go with the other y to the third power. Where should the 5 go? Where should the 5 go? I have a feeling this is maybe where some people got stuck. Chief?
With the 3 to the second power, the 3 to the second power is 9.
Right, with the 3 to the second power. Because they don't have letters. Anything that doesn't have letters goes together. Okay? Okay, so part of your homework's going to look like this. This is what you're going to have to do. Okay, the other part of your homework is going to look like this. Where instead of putting them in circles, we're just going to use different excuse me, use different shapes. Not really any more different, okay? So I'm going to start by putting a circle around the 2a. And then I'm also going to circle the 3a. Why would I put a circle around 3a? Gee.
Because it's like terms of 2a.
Yeah. So what should I put around the 5a? A circle. So I use the same shape on all 3 terms because they're all like terms. They both just have the letter A. Does that make sense to everyone? Okay, so if I follow that kind of same reasoning with number 5, I would circle the A. Can I put a circle around 2B? No, you need a different shape. How about a box? So I'm going to put a box around that. What shape would come next? Brady. Circle, because it's an A just like the first one. What shape would come next? T.
A box.
A box. How about next? Can I circle it? Can I box it? So I need a different shape? Maybe a triangle? Okay, so we would use a third shape in that case. Does that make sense to everyone? Okay, so let's try number 6. I'm going to put a circle around the Y. Yes or no? Would I circle the 4? No, because Y was a circle. 4 might have to be a box. Can I circle the 2x?
No.
Can I box it?
No.
Oh, why not? T.
So it's not the same variable.
Right, it's a different variable, so I need a different shape, so I'm going to put a triangle. Circle, box, or triangle for the last one? Circle, because it's a Y like the first one. Questions there? Okay, so I want you to write this example in your notes. I'll just show you one at a time. And those of you at home do the same thing. So number 7 here is 7x minus 3x plus 8x squared. Write that in your notes. 7x minus 3x plus 8x squared. And circle, box, triangle, the like terms. Did yours look like that? Hopefully. Now, could have you done 2 boxes and a circle? Sure, that's okay. As long as the correct ones have the same shape. Could have you done triangle, triangle, box? Yeah, I don't care. I just think circles and boxes are easier. Okay, write this one in your notes. 12a to the second power plus 4 plus 3a to the second power minus 2. 12a to the second power plus 4 plus 3a to the second power minus 2. And put circles and boxes around it. Hopefully yours looks the same. Minus circle, box, circle, box. Could have been box, circle, okay? Last one. Write this one in your notes. 3 plus 2d to the third power plus d plus 3d. So mine, I did circle, box, triangle, triangle. Why couldn't I put a box around these last 2 terms like I did the second term? They all have the letter D, but why couldn't they all be the same? Brady? Yeah, the exponents, right? So the second term, 2d to the third power, has that little 3. Those last 2 don't have that, so they have to be different. Okay, questions there? Any questions on that? Okay, so now it's super important. I have to